To complex numbers, we are going to take a look at quadratic equations again. So I know that we have already learned how to solve quadratic equations. So we're going to review a little bit on how we do that. But then we're going to look at some possible solutions that we've not counted before. So before, if we ever got a negative number in our discriminant or a negative number in our radical, then we simply thought that we did the problem wrong and we would look at it again. However, now that we've been introduced to complex numbers, we can actually get answers. We can actually solve for x, and those solutions be imaginary complex numbers. Let's review. The quadratic equation in its general form looks like this. ax squared plus bx plus c equals 0, where the coefficients a, b, and c are very important to us. The coefficient a is the coefficient in front of x squared. The coefficient b is the coefficient in front of the x term. And then our c value is our constant that does not have an x variable next to it. And then always when we're trying to solve a quadratic equation, we're going to want to get it set equal to 0. So if it's not set equal to 0, then we need to do that first. So for example, if we have 6x squared plus 13x plus 5 equals 0, our a would be 6, our b would be 13, and our c would be 5. A quadratic formula is quadratic equation is using the quadratic formula. So remember, we're solving for x, and we know that x is equal to negative b, or opposite b, plus or minus, which means we're going to get two answers, the square root of b squared minus 4ac, and then everything divided by 2a. So the b that you see, the a that you see, and the c that you see, those are all from the quadratic equation, those coefficients in front of the x variables. That the discriminant is what's inside that radical, that b squared minus 4ac. And the discriminant is important to us because it lets us know the nature of our solutions. Quickly, the nature of the solutions based on the discriminant. So if our discriminant is equal to 0, that means that we're going to have one solution. That means x is going to be equal to one number. Actually, what happens is that we have two equal solutions, which means that you're not going to write the same number down twice. You're just going to write it once, which is why we say if your discriminant is equal to 0, then you're going to have one real solution. If your discriminant is a positive perfect square, then you're going to have two rational solutions. Get rid of it without getting a decimal. That means you're going to have two irrational solutions. And then finally, if your discriminant is negative, and up until this point, if your discriminant is negative, typically we were like, uh-oh, something went wrong, do it again. But now that we've been introduced to complex numbers, we can say, if your discriminant is negative, you're going to have two complex solutions, or two imaginary numbers. Discriminant, which is the b squared minus 4ac, and then determine the nature of the solutions. The discriminant, and we'll do a practice problem, of 2x squared minus 9x minus 18 equals 0. So for this one, we would get the discriminant is equal to 225. And that's because we did b squared, so we did negative 9 squared, which gave us 81, minus 4 times ac, so 4 times a, which was 2, times c, which was 18. Okay, so when we do that, we end up with 4 times 2 times 18, which is 144. So we did 81 all right, and then we'll end up with 225. So if we know that, the next question is, well, if we know what our discriminant is, what is the nature of our solution? Well, since 225 is a perfect square, when you square root it, you get 15, that tells us that we have two rational solutions if we were to finish out the quadratic formula. All right, so let's try this one. Let's see if we can figure out what the discriminant is. Now, don't be confused by the z's. Z is just another variable instead of x, but you could still solve it the same way. Just think of the z's as x's. So you should be doing b squared minus 4ac. Our b in this case is 16. And then, so now if we're looking for 4ac, so that's 4 times a, which in this case is 1, because the z squared has a coefficient of 1 in front of it. And then our c is negative 6. So when we multiply that, we get negative 24. So we get 16 minus negative 24, or plus 24. So our discriminant is 40. So knowing that our discriminant is 40, okay, well then what is the nature of our solution? You should have gotten to irrational, because the square root of 40 is not a perfect square. I mean, it can simplify, but if you just do the square root of 40, you would end up with the decimal. So that means you're going to get two irrational solutions if you were to follow through on the quadratic formula. Let's do some practice actually following through on the quadratic formula. So now we have 4x squared minus 12x plus 9. So go ahead and see if you can solve it for yourself. A clue that I'm going to give you is that your a is 4, your b is negative 12, and your c is 9. Just a reminder of the quadratic formula, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So plugging in our known values, we should have negative 12 plus or minus negative 12 squared minus 4 times 9, all divided by 2 times 4. So after simplifying that, you would get 12 plus or minus the square root of 144 minus, let's see, 4 times 4 times 9 is 144. All divided by 8. So then you end up with 12 plus or minus the square root of 0, which is 0, divided by 8. So you get 12 plus or minus 0, which is 12, and then over 8. And then 12 over 8 reduces to 3 over 2. So you should have gotten option number 1, 3 over 2. Let's try another one. So notice how in that previous question your discriminant n was 0 and you got one rational solution. So let's see what we'll get this time. So in this case, our a is 1, our b is negative 3, and our c is 5. So when we plug this in, we'll get x equals negative 3 plus or minus negative 3 squared minus 4 times 1 times 5 all over 2 times 1. So we'll get x equals 3 plus or minus 9 minus 20 all over 2. So notice how 9 minus 20 is a negative number, right? 9 minus 20 is negative 11. So that means that we're going to have a complex answer as your solution. So you'll get 3 plus or minus the square root of negative 11 all over 2. Let's go ahead and take that denominator and put it over each term. So we'll get x equals 3 over 2 plus or minus the square root of a negative 11 over 2. And then remember, the square root of negative 11 is the same as saying the square root of 11i. So that means our final answer should be 3 over 2 plus or minus the square root of 11i over 2, which is option number 3. One more problem for you to try to do. So for this one, your A value would be 5, your B value would be 4, and your C value would be 3. So when you plug it into the quadratic formula, you should get negative 4 plus or minus square root 4 squared minus 4 times 5 times 3, all divided by 2 times 5. So you should get negative 4 plus or minus 16, and then 4 times 5 times 3 is 60, all divided by 10. Let's go ahead and take that 10 and put it under each term. So we get negative 4 over 10 plus or minus 16 minus 60 is negative 44. So we get the square root of negative 44. Our discriminant is negative, which means that we're going to have 2 complex solutions. All right. So 44 is not a perfect square, but we do have to go ahead and rationalize it. So 44 breaks down to 4 and 11. 4 breaks down in 2 and 2, which means that if we go ahead and simplify, we had negative 4 over 10, which is the same as negative 2 over 5, plus or minus the square root of negative 44 reduces to 2 square roots of 11i over 10. And then that 2 over 10 is going to go ahead and reduce to just the square root of 11i over 5. So we end up with option number 2. All right. I hope that this was super helpful to you.